All right. Hello, everyone. Welcome to the stream. This is my official first stream since yesterday. The technical issues were a little bit in our way, but hopefully from now onwards, everything will go more smoothly. Can you just confirm if you can all hear me? Right. So today we're just going to talk about all of the concepts that you guys are going to be focusing on for exam prep for the end of year mathematics reasoning topic. So let's dive right into it. So for today's agenda, we're going to talk about three main topics: number and algebra, geometry and measurement. And just before we talk about all of our exam prep topics, I would like to talk a little bit about effective learning strategies. Just so you guys can use your time effectively before the exam. You've got other subjects as well to study for, and you can use the knowledge that I will give you from those for other subjects as well. Make sure you stay until the end because I've got a surprise for you that will help you with the exam preparation. So let's wait for those. Just make sure that everyone has a pen, paper, and their scientific calculator with them because we will be doing some examples. And for those examples, I will also show you how to use the calculator. So it's good if you have it ready so you know which buttons to press in the exam. So for today's goal, we're going to go through all of the concepts that are going to be asked of you for the reasoning examination. NZQA has published a list of all the concepts that you should know before sitting this exam. So we'll go through all of those and making sure that you are aware what you need to know. Now, make notes of all the topics that you might not know, the topics that you might not have realized that are going to be assessed. Not every single one of those concepts will be in the exam because we don't know what is in the exam at the end. So, yeah, but this is just all of the concepts that you could potentially encounter. Just a quick introduction. So I'm Marcel, or Cel. I have been a tutor for 12 years. And I would like to bring all my experience now to the online world. So I would like to have a much wider student base that it can access my tutoring experiences. So this is the start of it. So thank you for being here. So about the effective learning strategies, let's dive right into those. The first part that comes up in research over and over is active recall. It is very important that when you are learning your notes, not just for mathematics or statistics, that you're rethinking what you're looking at. Make sure that you are covering your notes that you're trying to remember. Cue cards are a really good way to do this, even though just before the exam, it might be a bit too stressful to create a lot of cue cards. Make sure you're just turning your page, trying to memorize those notes, look through those notes again, and see if you can remember. Try and answer questions just by looking at the back of the page and then check at the end if you got it right. Remember, repetition is key. And with repetition, I mean spaced repetition. So you rather want to be doing your learning, you're studying 5 minutes a day, every day for a week, than one day where you have a 4 or 5 hour study session. So make sure you get onto it now. We have got enough time for the exam to be looking through those on a regular basis. In the research, self-talk is one of the strategies that comes up all the time that helps students and adults as well to do problem solving, especially in mathematics. So what do I mean? I mean asking questions. Talk to yourself in your head. What does this question want? Just like you and me are going to have a conversation in our lessons, I would like you to have a conversation with yourself during the exam. All right, let's start with our first topic. Our first topic is really big. We have a big topic, number and algebra. There's a lot of topics to be covered. So let's have a look what our first topic is. Remember, I can see you guys in the chat. So if you guys have any questions, pop them right in there and I will answer them as we are going through these topics. So the first part is going to be manipulating equations. So how do we add and subtract terms? I assume that all of you guys are able at this point to identify what are like terms. So just remember, like terms are terms that have the same variable. So we are looking at the x or the y, the letter that we have here. These are all different like terms because of the letters. When we're looking at like terms, we also need to be able to check the powers. So x and x squared are two different terms. We cannot put them together when we're adding or subtracting. Right, let's have a look at a couple of examples together, and this is why I was a little bit late. I wanted to make sure that my tablet was working so I can work on those. So let's see, can you all see my tablet, my screen? I think that should work. Yeah, I think that should be fine. Perfect, wonderful, I'm glad that worked. Okay, so when we have like terms, as we said, we want the same variable, in this case x, and if one of them is an x squared and x cubed, they are not like terms. We cannot add or subtract them together. So next part, if we do have two like terms, so for example 3x and 4x, how do we put them together when we add or subtract? We mainly look at the coefficients. So we look at the numbers in front of the x, and these are added together. It is important that you remember that the x or whatever letter that you've got, that remains exactly the same. So in the end, if we have 3x's and 4x's and we put them together, that means that we would have 7x's altogether. I usually make an example talking about fruit. I like fruit when it comes to like terms and learning the basics of algebra, because when you have a bowl of 3 fruit and 4 fruit, you can think of these as the x's. And if we put them together, we still have fruit. So, but now we have 7 fruit altogether. So we're just looking at changing the number in front. What do you guys think? Are these like terms? Could we put these together? So we have one no, one yes. Okay, so let's have a look. These two terms are separated by nothing on paper, but in mathematics we always have times in the middle. So if we are looking at these, they might look a little bit different, but they are the same term, because with multiplication we can turn those around and make them exactly the same term. So we can put these two together. Awesome, wonderful. So what about multiplication and division? How do we do this with terms? Now, it is important to remember like terms is only for plus and minus. We don't require that for multiplication and division. So when we do multiplication of terms, I usually always focus on one by one. I do the variables separately and the numbers separately. So it's always easy to start with the numbers, because those you can just put in the calculator and see what answer you get. So just like before, let's have a quick example. So we have 3x multiplied by 4y. And again, we don't need the x's and the y's to match for multiplication. So we're going to start with just the numbers. So here we have 3 times 4. That is easy. That is 12. And that becomes the number in front. Now I look at all of the terms and look for x's. In this case, we have an x here, but no x in the second term. So we're just left with 1x in the answer. For the y's, the same thing. We only have 1 y, which will be in our answer. Okay, what about if we have 3x squared y times 4xz? And I should do the x's like this to separate them from my times. So how do we do this? Well, the same goes again. We look at our numbers first. 3 times 4 becomes 12. Then we have our x's, and now here we have an x squared and an x. So together we have an x cubed. We have 1y and 1z, which leaves us with this term as the answer. Now, this is most of you will be able to do this very easily. I just needed to make sure that everyone is aware, because we will be using this for our whole number and algebra topic. So, when it comes to simplifying, we want to, as a goal, we want to make sure that the terms that we have are so compact, put together as much as possible. So here we can see we've got 3x plus 4y minus 2x plus 0.5y and plus xy. And again, everything is added. So we recognize that 3x and minus 2x are like terms. So we can put those two together. 4y and plus 0.5y is also like terms, and xy is by itself. So this is the fully simplified expression. So one of the first concepts that is going to be used all the time for this exam is going to be expanding brackets. So when we use expanding brackets, this is the way of us splitting two numbers that we normally would when we doing calculations in our head. So because we don't have all the numbers anymore, some x's, some y's might be in there, we cannot longer calculate the brackets first like BEDMAS would tell us. So what we do is we want to get rid of those brackets by expanding them. And here we've got an example, x multiplied by, in brackets, 2x plus 1. And we'll do a couple of examples in a second. But you guys should know that when you expand brackets, the goal is to get rid of the brackets and to leave you with something that is plus or minus, no longer multiplied. So again, let's have a look at a couple of examples. Let me just delete all that. So if we have x times 3x plus 4. So again, when we want to expand this, whatever is in front of the brackets, we want to multiply with each term in the brackets. So in this case, the first calculation would be x times 3x, and we're multiplying, so there's a 1 in front of the x that we normally don't write. 1 times 3 is 3, and the x's together, x times x becomes x squared. For the second part, x times 4, we're just going to be leaving 4x, and this will be our final answer. Most of the time, we will be expanding brackets that have multiple terms in them, and we've got multiple sets of brackets. Now, in this case, what this actually means is we want to expand this part with x and this whole part with x plus 1. So here we end up with x minus 1 times x plus x minus 1 times 1. And now we could expand these separately one by one. Now, usually this is not how you guys would have seen this before. So it is important to think that expanding goes one by one. However, when you guys do this in the exam, you guys can straight away go to how you guys have learned this before with your, I think it's the claw method. I'm not sure what you call it. So let's expand 2x minus 1 and 7x plus 1. So here we want to connect each element or each term in the brackets with each other term in the brackets. So we're going to end up with 2x times 7x. Numbers first will be 14. X times x is your x squared. Then we're looking at 2x times 1, which is just 2x. Now, when you do the second part here, make sure that you take the negative with you. The number that we have here is -1. So a lot of people will forget this negative. So don't be one of those in the exam. We have -1 multiplied by 7x, which will be -7x. And again, for the last one, -1 times 1 is -1. Now, every time when you expand brackets, yeah, foil, that's correct. Yeah, I think if you draw pictures here, it looks kind of like a claw for those crabs. So that's why I think some people call this a claw method. Yeah, so just remember when you answer this at the end, check if there needs any simplification, if you see any terms that are the same. Right, wonderful. Make sure that you're aware on how to do all the expanding. You would have probably done lots of expanding throughout the year. Now, the opposite of expanding is factorizing, and we use this all the time when we are solving quadratics, and we will have lots of questions for the quadratics later. So there's lots of different methods that we use for factorizing, and this can be very, very hard. So the most important part is that you guys recognize which one of those factorizing methods you use. So let's go through them one by one and have a look what we need to look at, what the difficulties here are, and make sure that you guys know the rules. We're probably only going to have time to do one of each, so it's very important that you guys make sure that you are aware on all the rules on how to go through one by one. So the first one is the normal factoring out common terms. So let's say we have 3x squared yz cubed plus 6 x yz. So this is clearly a complete scramble of all letters and numbers. If you get anything like this, you usually need to use this method where the only thing you need to factor out is a common factor for the numbers and the variables, so the letters that they have in common. So here, if we just look at the numbers again, 3 and 6. So what factors do they share? They share the factor 3, so we're going to be able to factor out the 3. Now, we're going to check all of the variables as well. Here we have x squared and x. So what do they have in common? They both have exactly 1 x in common. I should take that one away. Now let's have a look at the y's. Again, both of them have exactly 1 y. And the z's, well, we have 3 z's here and 1 here. So we have 1 z that we can take out. Now, if we're going to take this out, what we're actually doing is think about the backwards of expanding. If we are expanding, whatever is in front of the brackets, we multiply with the terms inside the brackets. So if we're now taking them outside of the brackets, we're removing them from these terms, then we need to do the opposite operation. So we need to divide by this. So what we're going to do is we're going to divide each term by what we're trying to take out. So let's do this term first. Again, we're multiplying or dividing, so you guys know by now, numbers first. 3 divided by 3 is 1. 1 as a factor we usually don't need to write, but if you do, that's totally okay. We now go through all of the letters one by one. We have an x squared and we are dividing by x. So we're going to be left with 1x. Here we have 2. Here technically we have 1. So if we take that away, we have 1 left. We both have 1y outside and inside. So if we take that one away, we're not going to have any more y's left. So there's no y left here. For the z's, we have 3 and 1. So we're going to left with z squared. And hopefully you can follow that the last one will just be plus 2 because of all the letters being the same. Now this method is most likely not going to be in your exam. but just in case you need to use it, if you've got complicated expressions, this is what we can do. The methods for factorizing that you're most likely going to encounter are all of the methods that include quadratic equations. Now, you guys should know that equations in the quadratic term have ax squared plus bx plus c in the standard form, and we've got some more slides about those coming. Now, if we have any of these forms and we want to factor, then we want to make sure that in front of the x squared there is a 1, or basically there's no number at all. This is the standard form of factorizing. Now, if we want to factorize this expression now for a quadratic, we always look at the end term. This is an easy example, but the steps that we're going to take, you can take for any other quadratic. Now, some of these might not be able to be factorized, but most of the questions that you're going to encounter in the exam will be able to be factorized because they will give you the opportunity to show them what you know. So we're going to take the number at the end, which is +1, and we're going to write down all the possible factor combinations. How can we get 1 if we're multiplying numbers together? The only way is, in this case, 1 times 1. If we have multiple parts here, we need to check which ones make this middle number. And there's a little trick. If these numbers add together, you check if these two numbers add or if they subtract together to get this. The combination that you need here is you want to make sure that the numbers that you pick in the end multiply to this end number and add together to this. Once you've written down all of your different factors, you can take any of those as positive or negative. So we could take +1 and +1, -1, -1, and any combination. For our example, we need to not check, but there's only one of these combinations that will work to get to 2 if we add it. Here we need both +1 in order to add to 2. Now the numbers that we have now circled here in purple, these are the numbers that we use when we factorize. So in the standard form, we always do 2 brackets and we always have x's on the left side. Now the only thing we need to do is we need to copy both the sign and the number that we have chosen. So in both cases, we have x plus 1 and x plus 1. Now, this is the standard way of factorizing. When you have a question that has a number in front of the x squared, this becomes more complicated. But there's a quick fix. Sometimes. Okay, now we've got much bigger numbers this time, but what we really notice here is the number in front of the x squared. This tells us that we need to use a different method, a special method. In order to make this easier, we want to make sure that we first check, can each number be divided by the number in front of x? If this is the case, you're lucky because then you don't actually have to do anything more difficult. It's again the standard way of factorizing. But we first need to factor out the 4. So we divide everything by 4, and you will see this will leave us with the same equation that we have just factorized before, but with a 4 in front. Well, the 4 in front doesn't stop us from factorizing this 1 by 1. So we're again getting x plus 1 and x plus 1 just like before. If this is the case, it's very easy because you don't need to do any different method when you're factorizing. It becomes more complicated when you cannot divide this. And I haven't got an example right now, so we're going to just do some quick We're just going to do some quick expanding to get an example that we can figure out. So if we have 3x plus 1, multiply 2x minus 1, and you can see if you can do this with me at the same time. So we're going to expand each part again. So we're going to get 6x squared minus 3x plus 2x and then minus 1. And we're going to simplify the middle terms because they are going together. Minus 3 plus 2 is minus 1, minus 1. So now we're going to assume that we don't actually know what this method is factorized. So, but what we do see is when we get this question, we see there's a 6 in front. We can't use the standard method if there's a 6 or a number other than 1 in front of x squared. We also notice that not all the numbers are divisible by 6, so we can't use the trick that we've just used before. So what we're going to do is we're going to do it almost the same way, but just slightly different. We're going to take the number in front and we're going to multiply it by the end. This will give us negative 6. Now, usually it's up to you if you want to keep the negative here or not, or if you want to ignore that for now. But just remember at the end, we want to have here a negative number. So the factors of 6 are now 1 times 6, 2 times 3. These are all of the factors that we can get in order to get to 6. Now again, we check which ones of those will we need in order to get the number in the middle. The number in front of the x in the middle is in this case minus 1. Remember, the 1 is usually an invisible number when we talk about multiplication. And now if we now look at this negative sign here, if we have a negative sign in the last number, and you can use the same trick for the standard method, that means we need to subtract those two factors in order to get the middle number. The reason for that is because one of them has to be positive and one of them has to be negative. If that is a positive, like in the question before, both of these can be added to get to the middle number. So now we want to check 1 minus 6 or 6 minus 1 does not give us minus 1, but 2 and 3 will work. More precisely, we want a positive 3 and a negative 2, because in combination, they will give us the minus 1 that we want. So just like in the standard method, we can now write our x's on the left-hand side in 2 brackets. And we again copy those 2 numbers that we have just found, just like that with the same sign. So we're going to get plus 3 and we're going to get negative 2. Now, this is not the standard method, so we're not quite done. We need to remember the last step. And here in the beginning, we multiplied by 6. So what we need to do is we need to divide both of these numbers by 6. Now, you guys are free to use the calculator if you want to, because there will be fractions. All you need to do is simplify these fractions. So 3 over 6 is 1 over 2, because we can divide the top and the bottom by 3. And 2 over 6 is going to be minus 1 over 3, because we can divide the top and the bottom by 2. Every time when you get fractions that are left over, this just means that the number that is at the denominator needs to be moved in front of the x. So we end up with 2x plus 1 and 3x minus 1. And let's check. Yes, that is exactly what we had before when we started expanding. The last method of factorizing is the one that students struggle the most with because they just don't recognize what to do. We don't actually need the same variables in this point, but what we recognize is that we have a minus. We have 2 terms that are minus. Usually when we factorize something, that minus is a giveaway of what you need to do. let's keep the y squared actually out just for this example, because in your examples in the exam, you're most likely going to have something with an x squared and then a number. So what do we do here? Can we use the same strategy that we have used before? No, we can't, because the number in the middle is not existent. Well, that's not quite true, because we could have plus 0x in the middle. And if you actually wrote this out and went through the same steps, you can work out the same way. But there's actually a really easy way of doing this in one step. Sorry, I'm just going to write this here. You guys can write this down. It's on the notes later on. So this is called difference in squares. And difference, remember, means minus. And this is where the minus comes from. So we're going to get something that is minus. And it says squares. So there is something in both cases that is squared. And as long as we figure out what these parts are, we're basically done in one step. So let's have a look. Which number, and we'll start with this one, which number squared will give us 4? Well, 2. 2 squared is 4. So we figured out what is in the box to get this part. In order to get this to this part, we need to figure out what is in the box below. So again, we do numbers first. Which number squared gives us 9? That is 3. You can do the square root of 9 in the calculator if you're not sure. And how do we get x squared? Well, the square root of something squared is just the value by itself. So we just have the x by itself. So now what we did is we rewrote the first part into a special form where we have a difference between squares. And now we can immediately jump to the answer, and all we need to do now is copy the first one, 3x, just like in our standard form. We need to now copy the 2 as well, because we figured out this is the second part. And if you now remember the last part, we need one of these to be positive and one of these to be negative. Then you already have the answer. And sometimes, if you've got some practice, you can go from here to the answer in one step. Again, the hard part is to recognize when we use this method. Yeah, just remember, if there is no middle term, that is usually a giveaway that you need to do this. They will never have no middle term and then a plus, because that you cannot factorize. All right. The factorizing parts are definitely the harder parts for this exam. Knowing when to use each of those formulas, when to use each of those factorizing methods, but we will see how we can use this in the calculator. The higher questions, merit and excellence questions, will require that you know how to do this, because they will put a K or an A in the question that you cannot put in the calculator. Okay, so let's have a look at solving some equations. When we're solving an equation, what we actually want to find is we want to find what the variable is. So for example, we want to find what x is. We want to find what y is. In order to do this, we usually have an equation that has an equal sign in the middle. So remember, every time you have an equal sign, we have 2 different parts that are exactly the same. So if we want to change something, we need to change it on both sides to keep this equality going. In order to move one part to the other or to get rid of it, whichever way you want to think of, we need to do the opposite operation of this. Sometimes it can be a bit difficult to figure out what the operation is. So if you're not sure, I always encourage you to ask yourself, remember, talk to yourself, what is this part doing to my equation? Now, unfortunately, you've always learned BEDMAS is the order that you need to do your calculations in. However, when you're solving equations, you're undoing the order that it's actually giving you. So what you need to do is you need to follow this backwards. And let me have a look. I'll show you a quick example. You probably do this yourself without thinking already. So, for example, if we have 3x plus 10 is equal to 2. Now, here again, we want to know what x is. Our answer is hopefully going to be x is equal to, and then whatever else we have is here. This is going to be our goal. Now, when I first introduce students, I always ask them, what is in the way? Why do we not have that x equals situation? And usually students will tell me, well, there's a 10 and there's a 3 that I don't like. So we need to get rid of them. And again, now we need to decide which one we need to do first. And you probably instinctively already know that the plus 10 needs to be removed first. But the reason why we do that is because here we are first multiplying by 3, then adding 10. And to undo this method, to undo these steps, we need to do it in the opposite order. So we first need to subtract 10 on both sides. So we're going to do minus 10 on both sides. Where's my blue gone? There we go. Okay, so what's left? Well, the 10 and the minus 10, they go to 0. There's not going to be anything left here. And again, if you have something left, you've made a mistake because your goal was to get rid of the 10. Now, on the other side, again, you have a calculator. Use it if you have to. This is minus 8. Now ask yourself again, well, do I have x equals? No, I don't. I've got a 3 in front. So how do we get rid of the 3? Well, what is the 3 doing? The 3 is multiplied by x. It's very tempting to just write minus 3 on both sides to get rid of this part. But we can't do minus 3 here because minus 3 and x are different terms. They're not like terms. So here we want to get rid of the 3, and the 3 is multiplied by x. So we're going to divide both sides by 3, leaving us with the answer negative 8 over 3. Now in the exam, I always encourage students to keep writing fractions as your answers. However, at the very end of a question, when you're writing your answering sentence, make sure that then you're rounding your answer appropriately. Awesome. Now, just a few things about the quadratic equation. We have talked a little bit about it. There's 3 forms for the quadratic equation that you really need to know for this exam. The first one is going to be your standard form. This is the form that we always like to have our quadratic in. And when I say like, it's a little bit weird because this is the one that everyone wants as a final answer, but it's actually the least helpful for us. It doesn't really tell us much. If you look at this equation, and you should learn this equation by heart, I don't think it's on your formula sheet. So we have y is equal to ax squared plus bx plus c. For a, b, and c, these are going to be your coefficients. So what is a coefficient? A coefficient is a number that is in front of a variable. We've seen this before, and when we were doing our factorizing, but in this form, we just need to have a look at the number in front of the x squared. That's the a. That is our scaling. We will have a look in a minute what the scaling does to our function so we can understand what that does. The b, if you play around on Desmos and see what it does, it kind of moves the parabola a little bit sideways, but there's no real rule that is easy for us to visualize what this is doing. So basically, I'm going to go with we don't know what b is doing. However, c is the only real information that we get from the standard form. C is your intercept, your y-intercept. So if you look at the picture below, I have marked the y-intercept at 0, at y0, at the coordinates 0, 0. In this case, our formula would have a c equal to 0. Let's have a look at one of the forms that I use basically all the time. It depends in your exam what information they give you that will force you often which one you have to use. If I have an option, I will always go with this option. Now, the factorized form, this is the form where we get the same equation that we have just had before, but already in a factored form. Now, in this form, we have y is equal to a multiplied by x minus b times x minus c. So what do these coefficients mean? Well, we need to have a look. If we're factorizing these, what we can do is we can set y to 0 and then everything is multiplication. So for this equation that we have here, the a, b, and the c are different. They're different from the form that we had before. They mean something new now. Well, a, if you expand this out, is going to be the number in front of the x squared, so it's still going to give you the scaling. But b and c are going to give you your x-intercepts in this form. And this is why often this form is called the root form or the intercept form. This is also the reason why it's the most useful equation for us. If you look at the picture at the bottom, we can see that the x-intercepts are at x is 0 and at x is 2. And the equation that I've written just above, you can see that we have x minus 0 and x minus 2. It is a little bit annoying, but every time when we talk about x values in a formula, we need to flip the sign. For 0, it doesn't quite matter, but for the positive 2 that we have for our x-intercept, we now have to write x minus 2. This is the reason why in the equation at the top, we have a negative sign in. So all you need to do is substitute in our value 2, and it will automatically do this change for you. Just keep in mind, it's always good to be sure that you have changed the sign when you're looking at x-intercepts. When do you actually use this form? Well, the reason why it's so useful is because we can almost get the full equation just by knowing where it crosses the x-axis. Let's have a look real quick at an example. I just want to show you an application question that they can give you in class. Let's say we are in PE class and we are throwing a ball into the air. Well, maybe we can say we're kicking it from the ground so we can have our quadratic level with the ground. We're going to kick it up and then gravity is going to pull it back down at a different point. A lot of the times when you get these equations with a quadratic, you're going to be looking at objects thrown, objects falling, because gravity is a quadratic part of the equation. You also often get something like a bridge, finding a bridge because of some concept in physics that I'm not sure about. You guys can teach me, yeah, but they always have something in physics that they give you. Wait, does it say that x is 13? It's kind of cut off the screen. Oh, yeah, sorry. That was from the previous question, my bad. So we're just looking at the parabola here. Now, often they will give you information. So for example, we kick our ball and it lands, let's say 10 meters away from where we started. So if we look at this, then we already know 2 points. More precisely, we know the x-intercepts. Here we have 0, 0, the origin. And on the other side, we have the point, well, 10 meters away, so 10, 0. Just by knowing this fact that the ball is kicked 10 meters away, it lands, is enough for us to start writing most of this equation. We're going to use our factored form where we're going to have our scaling and we're going to write our brackets. And just remember, we need to change the sign. Oh, that was the wrong pen. We need to change the sign of each of these x values. So we're going to go with x minus 0 and x minus 10. Now, we're almost done. We almost have this equation already. The only thing that is missing is the a. And how to solve this one, we will figure out a bit later. But you can see why the factorized form is so helpful. If we wanted to do this with a standard form, all the standard form can tell us is the x-intercept. Well, that doesn't tell us anything about this ball. The third form is the vertex form. I like this form, but often this is not the one that they give you because they want you to really focus on those intercepts. Sometimes they do, however, give you a question like this, and you can recognize this if they're talking about the highest or the lowest point. Because you all know that a parabola is either upside down or the correct way up, like a U, or upside down. Now, either way, it has either a minimum or maximum, and this will always be in the middle by the vertex. The quadratic equation, you should know, is symmetric around the middle, so this is exactly the midpoint. Knowing that this is the midpoint is often important to find this point. They will not say find where the minimum or maximum is. They will tell you find the midpoint. This is a concept that you often use. Now let's have a look at the form. The equation is y is a times x minus b squared plus c. Well, again, a is our scaling. This is something you can learn for all the three forms. That holds true for all. But again, b and c again means something different. And the reason why this is called the vertex form is because now the b and the c are the respective coordinates of this vertex. So we can have a look at the bottom. We can see that the vertex of the quadratic equation I'm giving you is 1, negative 1. B in this case is the x coordinate of the vertex, so 1. And c is the y coordinate of the vertex, which is negative 1. So if we substitute those into our equation, again, just like with the factorized form, we're almost done building our equation. We just have the scale factor a again. Now, when we look at this equation, x minus 1 squared minus 1, again note that for the x value, anything to do with the x value, I reversed the sign, so it became x minus 1 inside the brackets. However, for the y value, it's different. I went down 1 because my vertex is as 1 minus 1, but still c is still minus 1. I did not change the value for c. Okay, we've just done one example for the factorized form, so let's now have a look at the vertex form. And we're going to be using the same example, just with a bit of different wording. So if we now have a look, we're still going to be in PE class. We're still going to be kicking a ball. And what we like to do is we want to actually make sure that we set this graph at the origin 0, 0. The reason for this is because we want easy coordinates. So if we're now kicking this ball, well, what happens? It's going to go up and it's going to fly somewhere, and we're going to have our parabola. Now, last time we knew how far away this ball was. Let's say this is a different ball and someone else kicked it. And now for this example, I'm going to tell you the highest point is 10 meters in the air. After 2 seconds. So here we're going to be looking at the height of the ball after a certain amount of seconds. So now we're talking about the highest point. So now we have been given information on what happens at this highest point. And more precisely, we've been given that the height in the air is 10 meters. Well, that seems to be the y value for this vertex. So if we want to find the vertex form here, we first need to find the coordinates of the vertex. So in this case, we're going to have 10 as our y value because this is as high as our quadratic will go. How can we figure out what the width is, or the time compartment here? Well, we have been given that after 2 seconds, that means here our x value is 2. Now we have the vertex coordinates, and we can easily in one step write down the equation of this quadratic just by knowing the coordinates. So again, we're going to write down our form ax minus b times x minus c. All we need to do now is substitute in our values. And if you remember, the b value is the x coordinate of the vertex. So we're going to end up with x minus 2, and c was, oh, sorry, I gave you the factorized form. What am I doing? X minus b squared plus c. I don't see any comments of anyone telling me I'm doing rubbish. Remember, I always do rubbish when I teach. No, not always. Okay, now b was the x coordinate, so we're going to substitute in 2. And c was the y coordinate. Now again, we're going to check and make sure the y coordinate is a positive number. That didn't change. The x coordinate here was positive, but in our equation we have a negative, so we're good to go. That looks good. Now the only thing that's now left again is to figure out what the a is. Doing a few questions using these forms is quite hard in the beginning, but once you've done this a couple of times, you will realize, oh yeah, I've got the x coordinates, let's use factorized form, and you're done. Or if you recognize you've got the vertex, cool, easy, I just write down my equation straight away. With a bit of practice, this can be a very quick and easy solution for you. Now, how do we solve for this a? We still need to know what the scale factor is. So if you want to solve for a, you need to know one more piece of information. We need any point that is not on the points that we have used to create the question. So if we use the factorized form, we cannot substitute in the x values or the y values for those intercept points. You can try, but you're going to figure out that in the end you're going to cancel out the a and nothing's going to be left. And you're going to end up with, oh, my a is gone, nothing to do. So that doesn't help us. If you use the vertex form, you can't substitute in the vertex itself. So as long as you substitute in any other point on this quadratic, you can solve for a. And it's really your choice, whichever one you like. I highly recommend y-intercepts, x-intercepts, if you haven't used them in the factorized form, because then one of the variables is 0. 0 is always easy to calculate, but I mean, you have a calculator, so by all means, any point that you know will do. Okay, let's talk real quick about roots. Roots are the x-intercepts for the quadratic equation. Again, this is our standard form. You should memorize that slowly, step by step. If we want to solve for roots, that means we want to find the x-intercepts. Now, x-intercepts all lie on a straight horizontal line where y is 0. So every x-intercept has, in fact, y as a coordinate 0. So what we can do in our equation, we can just replace the y with 0. I highly recommend having this in your notes. X-intercepts mean y is 0, and y-intercept means x is 0. If the question talks about any intercepts or you see it is on one of the intercepts, this will help you immediately what the step is that you need to do after this. So let's assume you figured this out and we have replaced y with 0. We're going to be ending up with a question where we have 0 equals to some equation, some quadratic equation, perhaps in standard form. Now, what are your options to solve here for x. Previously, when we solved an equation, what we wanted to do is we wanted to move x on one side and get rid of everything else. This is not going to work with quadratics. You're going to end up with a squared term and an x term, and either way, you're not going to be able to get rid of those or solve for them. So we need a different solving strategy. Now, I highly recommend writing down in your notes that if you see any equation with a squared, you need to first set it equal to 0. This is the first part that lots of students struggle with because they forget what to do. How do I solve this? As soon as you see an equation with a squared, you must write equals 0 and preferably write it in standard form unless you have already been given factorized form. Now, the next step from here would be to factorize. Well, why is that? Because we have 0 is equal to something. If a number is equal to 0, that means when we multiply two things together, we know that either one or both of the parts must be equal to 0. This is because of the 0 having the special property that anything times 0 is 0. You could also use the quadratics formula, which I believe will be on your formula sheet. Make sure you check. But you can use this formula just to substitute in your values a, b, and c if your equation is in the standard form. Now, if you're very confident and completing the square, this is a method of solving for x and y without any other help, such as factorizing, a calculator, or the quadratics formula. In fact, the quadratics formula comes from the procedure of completing a square. But for the sake of the exam, it is good to know any of those, but you're not required to any of those. You don't need to actually use them. So the method that I recommend for the exam is the calculator. Just solve it with the calculator. Do keep in mind that these are the ways that you can work out the roots, and they will at some point be, well, helpful. But in an exam that is on time constraint, that is just asking you to figure out what x is, you can put this in standard form and solve. We will do the calculator in a second on how to do that. So let's have a look at the quadratics formula. Check if this is on your formula sheet. The only thing you need to do here is find out if your equation is in standard form, ax squared plus bx plus c, and you need to substitute in those values into the equation. Now, be careful, you have to do this in the calculator twice if this is what you're doing, because there's a plus and a minus in front of the square root sign. So that means you first have to put this all in the calculator with plus square root of whatever, find the answer, and then the same again with minus the square root of everything else. And we don't need to do the complex number part. I copied the slide. I was a bit lazy in this one. Don't worry about those. Let's have a look, however, at the roots. It is important to remember that a quadratic can have two roots, one or none. So in this picture, for example, we have two roots. And remember, the roots are x-intercepts. If the vertex happens to be on the x-axis, then we only have exactly one solution for our roots. This happened to be a repeated one. So for example, you could have x minus 1 squared, but you will see this if you actually try to work out what the vertex form here is. I'll leave that as an exercise for you. We can also have quadratic equations that are above the x-axis, and here we can actually see there is no roots in the real numbers. We can't cross the x-axis. If you have a situation like this in your exam where your picture is showing this and they're asking you for intercepts, something has gone wrong. Okay, let's have a look on how to actually use the calculator. That will be much easier. We're just going to put this in standard form. Let's try with this example here. 1 second. So I just need to click on this. There we go. So hopefully you guys can all see my calculator. So let's have a look. We are going to go into menu and we're going to have to go into equation. So if we now go down, 1, 2, there we go. We want to go to equations. So it's going to ask us, do we have simultaneous equations, polynomials, or solver? I highly recommend to stay away from the solver. I have seen lots of students make mistakes using the solver. Here we want to go F2 polynomials because a quadratic equation is a polynomial. A polynomial is any equation that has any powers for x. So for example, x to the power of 5, x to the power of 2, or any of those combinations. So we're going to press F2 for polynomial. It's going to ask you for the degree, and the degree is the highest of those powers that we've just seen. So in a quadratic, you're always going to be pressing 2 because you have an x squared, which is your highest power. Now, you can check if you've done it right at the very top. If you see the standard form equation that we have discussed all this time, ax squared plus bx plus c equals 0. If you look at this equation, and I highly recommend double checking in an exam under pressure, it says equals 0. So make sure that in your question you have equals 0 first. Also, you can see A, B, and C. So this is in standard form. You can only use the calculator if you're in standard form. So the equation that we just had previously was, and I need to check, 2x squared minus 4x. So what would be the value for a here? A is the value in front of the x squared term, so that would be 2. What is the value for b? Well, we check for the value in front of x. And I try and look for those x squared and x's and think about the number before. This way you won't make any mistakes. Now, hopefully you're sitting there and you're recognizing that b is -4. A lot of students will now forget the minus. In the standard equation, b has whatever sign you have between terms. So here the -4. And what is c? Well, we don't have a number there. So we actually just have 0 here. And so you don't make any mistakes with where a, b, and c go. Try and think of c being the number without the x. Well, there is no such number. If we now press enter, we can see x1 and x2 is 2 and 0. So these are now our x-intercepts. X is 2 and x is 0. Just a quick tip. If you forgot how to factorize, you could put it in the calculator, find out what the roots is, and then backtrack by writing your factorized form. This might only be possible at the moment if you have whole numbers, but if you look at how we factorized when there was a number in front of the x squared term, you can write this in a special form. I will show you how to do this real quick for numbers that are fractions. If your calculator is telling you x is 1/2 and x is 5/9, then you can, just like before, write our factorized form. X is on the left, and then we have to substitute these in. But remember, these are x values. So what do you need to be aware of? Changing the sign. So we're going to have -1/2 and -5/9. And how did we deal with these fractions before? In the special form, we multiply those out the front. So we get 2x minus 1 and 9x minus 5, which should be exactly, again, the factorized form of your equation that you had to factorize. Awesome. This completes our topic on quadratic equations. So let's have a look at some patterns. Patterns come up a lot and we use X and Y tables, especially in the exam. If you see a question on patterns, usually you will also see an X or Y table, or they might ask you to create one of these tables yourself. Patterns can be in any form. It can be a straight line, it can be a quadratic like we've just discussed. So what we really need to know is when is one of these one of the others. Well, the XY tables can show us the coordinates of all the points of a graph. So the relationship between X and Y is hidden in the table itself. We just need to work it out. So by analyzing these tables, we can figure out what the equation of the graph is. Now, this could be a linear pattern or a quadratic pattern. Let's have a look at this pattern. You will recognize that one of the past papers has questions in this that just straight up give you an X and Y table and they're asking you for the equation. Well, the calculator can help you a lot here. It can actually do the whole question for you. You just need to do one thing. You need to identify what kind of question they actually give you. Is this a straight line? Is this a quadratic? Or is this something else? So if we're now looking at this X and Y table in front of us, what we want to make sure that each of the X values increase by 1. Otherwise, we cannot do this check ourselves. We might need more calculator help. So if we now want to check, the first thing that we do is the first difference. We want to check if the Y values increase by the same amount or not. So we're going to have our Y values, and if you have a look, they seem to be increasing by 2 each time. So that's a good sign for us to believe that this is a straight line, a linear pattern. Whatever the number is that we're increasing by each time, in this case plus 2, this will be the gradient of our line. Now, we also need the y-intercept to write our equation. In order to do so, remember what I said, y-intercept means x is 0. So what we need is the y value when x is 0. Well, they didn't give us the information for x is 0, but we were very close to it. Perhaps we can backtrack and get one step back to find what the value of y is when x is 0. So we will do the calculator option, but actually I will just quickly show you how I would do this in an exam, so you know you can just copy exactly the method that I'm using. We had our X and Y table with values 1, 2, 3, 4, and I think until 5, but that's okay. And our Y values were 4, 6, 8, 10, yeah, there was 12 as well, I remember. So what I always check is I check the Y value and I write these arrows pointing from one to the other. Well, how do I get from 4 to 6? It's plus 2. From 6 to 8 is plus 2. From 8 to 10, plus 2, and so on. This is what we call the first difference. If the first difference is always the same number, we have a straight line. And this is in fact, m, which is the gradient for the straight line. Remember, a straight line has the form mx plus b or c. Some people use b and c, it doesn't matter. In this case, we might want to remember that m tells us how steep our equation is. It's the gradient. B, however, is the y-intercept, because if we have x is 0, this term is gone. And remember, the y-intercept is when x is 0. Well, then we just have y is b. B is the y-intercept. So how do we find this y-intercept? Well, just like we had before, we have x is 0. So we actually want to know, so let me just move this a bit higher up. We want to know what is the y value when x is 0? Well, we know what happens each step. So what we can do, we can backtrack. Usually, it would be a plus 2 here. So what number plus 2 is equal to 4? Be careful that you're not accidentally doing the wrong one and writing 6 because you're adding 2. You have to go back, so it's minus 2. So this would be 2. Now we have the y-intercept, so we have the equation for this line, which is equal to 2 plus 2. Here 2 is the gradient, which comes from the first difference, and the 2 at the end comes from all the way in the top, the y-intercept. So let's have a look. How can we do this in the calculator? And remember, we just need to recognize, is this a straight line? So we need to check if the the first difference is the same. So the equation for a straight line is called y is equal to mx plus b, or y is mx plus c. If y is 2, then why wouldn't 2 replace 2? Okay, let me just go back to the tablet. So we have, so first of all, Melody, we have your equation, this equation here, that's the equation of the straight line, a linear equation. Here we have, this is your gradient, and b is your y-intercept. Sorry, I'm writing in the air, it's not so well written. So this is your linear equation. Yeah, and what else is this? If y is 2, then why wouldn't 2 replace 2? Oh, right. Let me just check. I think what you're saying is, wrong pen, hold on. What you're saying is if this y is 2, why wouldn't y be replaced with 2? Well, that's actually a very good question. Let's actually have a look what happens if we replace y with this 2. So we have our equation y is equal to mx plus b, and we know that our gradient is 2. So far we've got this. We now need the y-intercept, so this is 2. Well, y can be 2, but if y is 2, we also know that x is 0. These two go hand in hand. They are pairs. They are coordinates. 0, 2 is the coordinate here. So if we replace y with 2, that is correct. We can do that. But then we also have to replace x with 0. And now what the equation tells us is we have 2 is equal to 0 plus b. So we have 2 is b. So basically, you're right. We should have replaced the x and the y together in our equation. This is kind of just like a time saver. If we know that x is 0, which is the case here, then in a straight line, we're always going to get this term falling away. It doesn't matter what the gradient m is, because the value x is 0. Wonderful. Wonderful. That's a very good question, actually. Yeah. Thank you. Okay, so now let's quickly go and have a look how we do this in the calculator. Remember, we just need to identify that this is a straight line, and we do that by checking that it increases by 2 each time. So now we go into menu. And if you press one second, where's my calculator? Yeah, if we press menu and we go back to 1, this is our normal calculator, right? Now, if we go into menu, we want to be in stat, the statistics menu. So we go to number 2, and you should have now, you should now have a list of different things, kind of like an Excel table. All we're going to do is we're going to copy in our points that they've given us for this question. One of them, it has to be list 1, has to be the x value, and list 2 has to be the y value, in order of the alphabet, if you want. So if I remember correctly, it was 1, 2, 3, 4, 3 and 4, up till 5, and our y values were 4, 6, 8, 10, and 12. So technically we only need 2 points, because as soon as we have 2 points on a straight line, we can connect them and we will hit every point. There's only one way to draw a straight line if you have 2 points. However, for this question, just put in all the points. It will actually help you because you can double check if your working is correct. So let's see how. We want to press F1 for graph. And it doesn't matter which graph we use, usually just always graph 1. Well, first of all, we see it looks like they are all in a straight line. That's a good sign. If we now press calculate, now we need to tell the calculator now that it is a straight line. So the X here with the black in the back, that is the button that tells the calculator that we have a straight line. So we're going to press F2. Here we're always going to pick the first one, which is ax plus b. It's not a biggie if you get this one wrong, but you need to make sure that you check at the bottom with your equation. Now the calculator likes to write ax plus b. We like mx plus b because m is a very common letter that we use for the gradient, but it doesn't matter. It's just a letter. Now here, what I recommend is just copying the equation that they give you, y is equal to ax plus b, and then underneath it substitute in your values for a and b, which will give us 2x plus 2, just like we figured out by ourselves. Now, doing this in the calculator will give you one extra benefit. You can look at the r squared or the r value. Now, while this is a more advanced statistical concept that you will that you might encounter if you take statistics in level 2 or level 3, this value just tells us how good our straight line fits those points. And because we knew it was a straight line, that number has to be 1, technically 100%, 100% fit for those points. Well, no surprise there. Let's say you made a mistake and you pressed graph 1, you calculate, but you pressed F4 here because you thought this was a quadratic. The calculator will still give you answers, and no, this should not work. 1 second, graph 1. This cannot work. Do I have to press enter? Okay, so my calculator actually doesn't allow me to use x squared here. If your calculator gives you a number that is not 1, 0.9, lots of decimals, then you know you've done it wrong. Okay, let's have a look at the next part. Oops, this one. So let's look at a quadratic pattern. And again, it doesn't matter what pattern we get. The first thing we do is we check for the difference. From 0 to 1 is plus 1. From 1 to 4, plus 3. From 4 to 5, from 4 to 9 is plus 5, and so on. So we see straight away that the first difference is different. Yes, the live stream will actually be recorded, and hoping that there's no difficulties, but I will post this on the YouTube channel so you can review this after to check in the notes. Yeah. So if we now check for this pattern, let's again do that again together. We're always going to check for the first difference. I just need the numbers again real quick. 0, 1, 4, 9. Yeah, of course. 1. So we have our X and Y table, and we have 1, 4, 9, 16. 1, 2, 3, 4. Now, if we have a look at this, again, we do our sign plus how many there are. So plus 3. Here we're going to have plus 5, And here we're going to have plus 7. So what do we recognize here? Well, if these numbers are all the same, we know it's a straight line. So here we can straight away say this is not a straight line. So we don't know anything yet. We now actually check for something that's called the second difference. Well, here we already know what the increase is with each step. But does the increase increase? Let's have a look. We do the same thing again, and we recognize that these are, plus 2, and if we had more, they would also be plus 2 each time. So here we can now see that our second difference is always the same. If the second difference is always the same, this is a sign that you've got a quadratic pattern. So let's have a look at our information. Here we've recognized that this is a quadratic pattern. Now again, make sure that the values for x increase by 1 each time, or the difference check doesn't work. Now for quadratic, we check that the second difference is the same. There is a longer method to actually find what the equation is here. We can do simultaneous equations with 3 unknowns. Not so fun. We could also use like a little trick or like a rule. There's a way to finding A, B, and C, just looking at the pattern. Again, we're not going to cover these today, but the most important thing is we're just going to look at how you get the answer, because this will be part of the marking schedule. So you still remember you still have to identify that this is a quadratic. So if we now go to our calculator, what we can do is we can put again the numbers in. Where's my, there. I just quickly need to delete these. There we go. And our numbers should be 0, 1, 2, 3, 4, 5. And that should be 0, 1, 4, 9, 16, 25. There we go. So if we again press go back, graph, we want to go and graph this. And on graph 1, we're happy with that. And we can see that it's slightly curved. So maybe this is a quadratic. This is a good sign. Now, if we press on calculate, we used to press F2 for a straight line. That doesn't work. If you do, then, yeah, there we go. This is what I was trying to show you. Then the r squared or the r value is not 1. This tells us that we cannot combine those points in a straight line. So let's do it correctly. We need to tell the calculator that this is a quadratic, so we're going to press F4 for some term with a squared. And now it would tell us what A, B, and C are, and you can recognize the r squared value is 1, so we have a 100% fit. You can also see that you have your standard form, y is ax squared plus bx plus c. So by now you should be pretty good with substituting in those values to write your final answer. Now, sometimes we're going to be asked to draw patterns or to draw graphs. So let's have a look what we need to do. They will give you a big coordinate sheet that you need to fill out. And the key is that you mark as many points on there as you can and then connect them to find the answer. Well, let's see if we need to connect it each time. How do we get to this XY table? Because remember, the XY table tell us the coordinates of each of those points that are on this pattern. Let's do an example here for this one. But first, why do I now use T and N? Well, the reason for this is because, first of all, I want to show you that in an exam, it doesn't matter what the letter is that they use. May it be T for the term and N for the number of term. Well, or if it's X or Y, it doesn't matter. So don't get confused if you have a different letter there. Feel free to rewrite this as y is equal to x squared plus 2x minus 1 and do what you usually do. Okay, we'll have a look at the patterns that we don't connect in a second. Let me show you again on the calculator. Oh yeah, we still have that calculator up there. Perfect. So now we want to go into menu. There we go. Menu. And we want to now go to table number 7 on my calculator because we want to output a table. And what we're going to do is we're going to substitute in that equation that they have given us. In this case, it was x squared plus 2x and let me check, minus 1. Now, before we use the setting, it's important that we tell the calculator what we actually want. So we might want to look at the coordinate system that they've given us. Where does it start? Where does it end? So that we can see how far we need to go and where we are expected to draw our points. So if our coordinate starts with -5 and goes to 5, let's set those as the beginning and the end mark for our table. For this, we need to go and press the F5 button, set. So we're going to set the table and we want to start at -5 and we want to end at 5 itself. Now it's going to ask you for a step. Well, the step is going to tell you how often it will calculate those values for you. If your step here is 1, it will calculate for -5, 1 step each. So -4, -3, -2, and so on, all the way until 5. If your step is 5, it's just going to jump. So it's going to do -5, 0, and 5, nothing else. Let's keep it at 1. Once we're done with setting the table, we want to press F6 to get our table. And now we can see exactly the table that we've used to identify our patterns is given to us. Each combination here is a coordinate. -5 and 14 will be -5, 14, which you can mark in the coordinate system. I recommend marking these points with an X, exactly where it is supposed to be, instead of a little dot. A little dot is hard to see, but the X is much clearer. Once we've gone through, you can scroll down and we can fill in all the points that you need. You might not need every single one of them, but especially at those crucial points where it turns, you might want a few more so you know exactly how to curve your equation. Now, once you're done, I just want to say one thing. I always connect basically all my questions. As soon as you draw, you connect the graph and you're done. There's just one thing. In this part, they're going to try and trick you by using patterns when you are drawing one of these equations. Because they can test you on two things at the same time. One, do you know how to get the table, like we've just done on the calculator, to draw your lines? Two, do you understand what a pattern is? So they do this very often, and lots of students forget this under exam pressure. So when we have got all of our points, for every graph, equation, whatever, we connect. And we go all the way to the edges, to the ends of our coordinate system. But here's the catch. If this is a pattern, so for example, they might give you like a picture with what do you call them? Matches. And each time there's like a certain amount of matches more. Each one of those patterns or pictures only exists for one of these patterns. So there's no in between. If we have a pattern that has more matches, like 5 increased each time, we can't have half a pattern. So if your question is about a real life situation, just think, can I have half a step? The numbers will work, but in reality, can I have half a step of a pattern? And normally the answer is no. So if you have a pattern question, you still do the same thing. You get your table, mark all your values, but you don't connect. Also be careful, they will give you negative values as an option to mark. But a pattern only starts with x is 1. So if you have a pattern, you might want to set your table to start at 1 with step 1 and only mark those ones. You will be marked down if you mark 0, x is 0, or negative numbers if this is a real-life pattern. Okay, now, connect all the way up till the end. Okay, the last topic, I think this is on our algebra topic, is simultaneous equations. Here's an example of a simultaneous equation. So what does that mean? That means we're solving multiple equations at the same time. We have as many unknowns as we have equations. So here we have x and y as two unknowns, so we have two equations. This is also how we recognize if we need to use simultaneous equations, because they're going to ask you to solve for multiple things. Now, we're not actually going to solve this using one method together because we're going to run out of time, but I will show you how to do this in the calculator. And as soon as you set up your equations in the exam, you are allowed to just substitute these into the calculator and see what you get. So for the calculator, we're going back to the equation tab where we were last. And from there, we want to now pick simultaneous instead of polynomial, so F1. The number of unknowns here is 2, and you're always going to be pressing 2. And now it's important that you always write your equations in that form that we have on the side, where the x's and the y's and the numbers are matched underneath each other. Because now all we need to do is substitute in our values. One part that we had was we had 2x plus 3y is equal to 12. So we have 2 for a, 3 for y. And if you look at the top on the calculator over here, it says equal to a number. So we don't want equal 0 for this setting. Always check what your calculator wants. The number in front of x is 1 and minus 1 for the other one, and the number is 1. So if we now press enter, we will get a value for x and y that will solve both those equations at the same time. You're just required to write down what this means in terms of the answer. So for example, if x is the number of apples, y is the number of bananas, then you need to write there's 3 apples, 2 bananas in the end. Okay. Substitution method, elimination method, graphical method, and matrix method. These are all methods that we can actually solve these by hand. I would always stay away from the graphics method because that's always tricky. You can never know exactly where you are. But all of these methods, if you're interested, you can ask about those. But these are not going to be covered today because for the exam, you are just required to put this in your calculator. Just a last quick reminder for the gradient for linear equations, you need to learn the sentence: for each one increase in x, there is an increase of the gradient in y, or a decrease if the gradient is negative. You can apply this to each of the straight lines that you have, and they might ask you to tell you what does it mean to have a gradient of 5. Also, I recommend learning this rule that the gradient is m is rise over run. Now rise is going up and down, so it's the change in y. Running, if you're running from left to right, that's the change in x. So from that point, you should remember that you can get to this equation. Y is at the top because it's a change in y. X is in the bottom because it's the change in x. And then you just make sure that the numbers y1, x1, y2, x2 match. If you're ever asked to find the equation of a straight line from a graph, you can pick any 2 points, write down the coordinates and substitute them right into this equation, and you've got the gradient. No hassle. However, it requires you to memorize these by heart. If you're asked to find an intersection point between two graphs, that means where they meet, where they cross over. So we're going to be we're going to look at one of these examples together to finish our algebra topic. So the two equations that we have gotten here is y is equal to x, and also y is equal to x minus 1 squared. Let me check. Minus 1. Yeah, minus 1. Minus 1. So if we have an intersection point, that means our two graphs cross over at a certain point. And at that point, the x and y coordinates are exactly the same, and they're on both equations at the same time. So what we're going to do is we're just going to write both equations in terms of y. And because the y's are actually the same number only at those points of intersection, we're going to be able to set these equal to each other because they represent each y. So what we have here is we have x is equal to x minus 1 squared minus 1. Now, if we want to solve this, a good idea would be to expand here. So we're going to get x is equal to, and I will expand this real quick for you because we're running a bit behind. So now we want to make sure this is equal 0. Why was that? Remember, when we were looking at these equations, we want to solve this when it's equal to 0. And we recognize this because we have a squared. So we're going to get 0 equals x squared. Now we have minus, so we have plus 1 minus 1. So we have minus 2x, sorry, plus 0. Now we can use factorizing here or whatever you want to use. You can also just put this into the calculator to figure out what the answer is. You can practice these when you pause the video later. So let's just quickly factorize here, x minus 2. So from this we get x is 0, or from this we get x is 2. So we actually have 2 points of intersection here, and we can see here on this graph, this was just a sketch to show you what happens when we have an intersection, so we no longer need this graph now. Just remember, when you're finding points of intersection, when you do this method, you will be able to find your x coordinates, but you might still have to substitute this back into y. So, okay, for our second topic, now the second and third topic are much shorter. The algebra is always very intense. So we're just quickly going to cover the geometry part. And if I wasn't 15 minutes late in my stream due to technical issues, we would be running on time. So for right angle triangles, what you need to know is Pythagoras theorem. You need to know that a squared plus b squared is c squared. So when do we use this? Well, if we have a right angle triangle and we're looking for the third side. If you want to, what you can do is you can substitute in your values for a and b and solve an equation similar to how we've done this before. You could also memorize the shortcuts that I'm giving you here to find a different side just in one step. Just be careful in this formula, it's very important that C is the longest side. It doesn't matter which side A and B are, but C needs to be the longest side. So in this case, the longest side is always opposite the right angle. If you're ever not sure or a sketch looks a little bit iffy and you're not sure which one is the longest, it's always the one opposite the right angle. So we're not going to do multiple examples together. We're just going to do one real quick. that should be enough because Pythagoras theorem is not that difficult to use. So if we have a right angle triangle, as long as you're using the equations that I've given you, you will be sweet. So if we have two sides here, 3 and 4, and we want to find the other side, well, let's have a look. The only important part to recognize is the longer side, which is x. So this is our c in the equation. Now, if you want to, you can substitute this in. We have a squared plus b squared is c squared. A and b, it doesn't matter, it's any short side. So 3 squared plus 4 squared is equal to x squared. And you can use the calculator here. This will give you 25. And now, how do we solve for an x squared? Well, the opposite is a square root. So we're going to get the square root of 25, which is 5. Now, in algebra, you get two options. You get +5 and -5 when you solve this equation, but we can ignore the negative numbers here because every time we use Pythagoras theorem, we use a real-life situation, so the line of x cannot be negative in length. If you wanted to use the one-step method that I have shown you, where I gave you the formula, remember you just need to memorize that formula. We get c is equal to the square root of 3 squared, which is a, plus 4 squared, which is my b here. Put this in the calculator and it will give you 5. We're just going to do one more example where we're going to be looking for a different side. Yeah, so always be aware which one is the longest side. Let's say this is 10 and this is 4, and here we're solving for y. Again, we can use our normal equation, a squared plus b squared is c squared, and substitute in our values. The only thing we need to memorize here is that c is the longest side opposite the right angle. So let's substitute in 10 for c. And all of the others don't matter. Now, if we simplify this, we're going to get y squared plus 16 is equal to 100. And if we move -16 on both sides, remember solving equations, then we get y squared is equal to 84. Now, if we want to find y, we just need to do the square root. So we're going to get the square root of 84, and you can put this in the calculator and find what value this is. Just make sure you round it maybe to 1 decimal or 2, depending on the question, whatever makes sense to you in a real-life situation. If you memorize the formula, remember here, these are the short sides. So we're looking for a short side, so we can just write down y is the square root. And now it's c squared minus b squared, or any other short side. So for c, we're going to go 100 squared minus 4 squared, which will be the square root of 84. Now, that was Pythagoras' theorem already. That's all you basically need to know to be applying the theorem. Now, right angle triangles also have trigonometry. So make sure that you remember SOHCAHTOA. You should be able to get to these triangles that you see here from scratch or from memory. Make sure you remember SOHCAHTOA to be able to write down these triangles onto your sheet when you're dealing with right angle triangles. Every time you see a question in the exam that has a right angle, you can use Pythagoras' theorem or trigonometry or a combination of both. So hopefully you remember how to use these, because these can actually be very helpful in getting your one-step answers. So let's have a quick look at just doing a couple of questions together for trigonometry. Again, we need a right angle triangle. Now, if we have 10 here and we have the angle, let's say 30 degrees. Now, if we wanted to find what we got here for this side here, or for this side, we can use trigonometry. So first of all, we need to recognize where the angle is, because sine, cosine, and tan always go with angles. According to where this angle is, you will be able to find the three other sides. I always start with the longer side, which is h, for your hypotenuse. Then we look at where the angle is, and the side opposite this is O, your opposite side. It looks a bit silly with two circles there. But the side next to the angle comes from A for adjacent. Once you get very familiar with these, you don't need to write these on there anymore. Just be careful that you're doing this correctly. We're going to check what we have given and what we're looking for. So let's start looking for x. Then we have been given O, the opposite, and A, the adjacent. Of course, we have an angle, which helps us identify that this is trigonometry, not Pythagoras' theorem. So we have A and O, and there's only one of those triangles that will have an A and an O in it. So let's have a look. We have our triangle TOA, T-O-A. And I like writing a times in the bottom to remind you if they're in the bottom, they are multiplied together. So if you want to find x, we just need to cover with our hand, and I can't really do it on the screen, but we're going to cover O. We're going to cover this part, which means the only thing left over that we can see is t times a. So that is already our one-step answer. So x is now equal to t times a. Well, we just need to figure out what does t stand for. S, c, and t are your functions sine, cosine, and tan. So if those are in your triangle, those are the ones that we want. And they always refer back to the angle. So here we have t, so we need to write tan. Well, and they always use the angle, so the angle here is 30 degrees. This is our t. Now we need to multiply by a, and a was the adjacent. We actually have a value for that, which is 10. So now we just need to put this in the calculator, and I'm sure you'll be able to do that. Just be careful with one thing. We want to make sure that we are set in degrees for our calculator. Let's do one more example, and I will show you how to check if you're in degrees. Okay, let's have a look at this example. Here again we have the angle. That's what we want. We know it's trigonometry because it's a right angle triangle. So now we need to figure out which one it is, sine, cosine, or tan. So let's have a look. We first write h for hypotenuse, O for opposite, and adjacent for the side next to it. We're looking for h, and we have a. So we want a combination of a and h. And if we look at our triangles, we see this is cow. So now we can write down y is equal to in one step. So again, we cover what we want to find. So we want to find, in this case, h. This is now gone. So what's left is a over c. Well, we have a over c. What does a and what does c stand for? A is our adjacent, so that is 10. And c, well, c stands for the cosine. But every time when we use s, c, or t, those functions refer back to the angle. So remember, this is cosine of 15 degrees. Put that in the calculator, and you're finished. The last thing that we need to do with trigonometry is we need to figure out what the angle is. So let's say we have an unknown angle theta, and we don't know what that angle is. Well, let's say this line is 5 and this is 4. Let's figure out what this angle is. Well, we're still using trigonometry, so we still need to know where the angle is, and we still have to mark H, O, and A. Now, in this case, we have been given O and H, so there's only one option for us to solve this. We need SOH, and here we have a line and a times. So, but now, if we're looking at this question, we would cover the S with our finger. So S would be completely gone. So if we want to now write down that our angle is equal to, and it kind of says O over H. Now, there's one thing you need to remember for trigonometry, and that is if you're finding an angle. Finding an angle, you still can use the triangle, but what we need to do is we need to do the inverse of our function that the triangles are using. Here we have an S, so we are supposed to use sine, but if we're finding an angle, we need to reverse this to using the inverse sine. Okay, I'm sure you can substitute in O and H over here. So this is the whole topic on trigonometry. Just a quick reminder on how to make sure your calculator is in degrees, because you will get every single question wrong in trigonometry if you don't have this. You want to go to options. You want to go to shift setup, shift menu for the setup. And now you scroll down and you're looking for angle, and you want to make sure that this says degree. So you can press F1. My calculator was set to radians, which is what you will be using later on if you continue with mathematics. So I will change it real quick to degree, just so I could show you these questions. Exit, and we can put this in. We had a question where we used the cosine, so we just used the cosine. Make sure that you use brackets. Oops, not there. Make sure you use brackets if you want to input something into the function. I don't know, we had maybe 45. Yeah. Another part that we want to make sure is that if you want the inverse, you need to press the shift button and sine for the inverse sine. And our numbers were 4 divided by 5 in the last example. So the angle from our last example was 53.1 degrees. So this is just a reminder that you use the inverse if you're trying to find the angle. Now they will give you trigonometry in a 3D example most of the case. Same with Pythagoras theorem. So what you can have a look here is some of those 3D shapes that they might give you. You will have to look around, where do we have right angle triangles? This will be the hardest part to recognize what you need to do. Similar triangles was not in the mock exam that they have presented with us, but it is on the list that you should know. So let's quickly have a look at some similar triangles. The proportion from one triangle to another is always the same. You should remember short to long, or short to short, long to long. Whatever you have first, you want to match after. Let's have a look at this triangle, and this is how we use this. We can see that all the angles are the same. Now, if we want to look at one or find out one of these sides, what we can do is we can use ratios to solve for these. Let's have a look. Short means we're looking at the short sides, the small triangle. Or we can have long for the long sides. So what we can do is we can go from D to E, that's the short side, and we can divide this by D to B, a long side. So whatever this side here is, D to E, and we divide it by the long side, that number again will give you exactly the same number as if you do this short to long by dividing a short side to a long side. You could also use the middle part, so we could do short to long. That number or that quotient will be the same as short to long. We could also do long to short, and so on. So, for our last topic, also a quick one, measurement. This is just about some of your formulas, just some recommendations. So the fundamental part that you should all know is that whatever they give you, you must always calculate in the same units. Make sure you get your unit conversion right. So if a unit becomes smaller, so from meters to centimeters, then we multiply the number by the ratio. The ratio is how many centimeters are in a meter. So we would multiply by 100. I would expect that most of you will be able to do this in an exam. Just remember that if they give you a question with measurements, you might need to first check, are they all in the same unit before you do your calculations. Make sure you write the answer with a unit at the end. One concept that they want you to know for 2D shapes is the perimeter. For perimeter, we go around the structure of our shape, and all we do is make sure that we cover each side. So when we are looking at a rectangle, we might want to pick a point where we start and just go across all the lines and add them together. Often they will use this in combination with algebra because they might give you a side, it might be x or x squared or y minus 7. And note that the perimeter for a circle is called circumference, and you will have these in your formula sheet. The second part that they want you to know about 2D shapes is the area. Make sure that you know the formula for most of the 2D shapes. By heart even. Triangles, rectangles, squares, I would expect you to know by heart. Check your formula sheet. You can see it online. If you go 2024 formula sheet NCEA, you will be able to have a look. Now again, remember the units at the end, if you're talking about an area, are squared. Whatever you write, centimeters squared, meters squared, and so on. The surface area is a concept that they need you to know for 3D shapes. So this is just the area of each of the faces of the shape. So if you have a cube, then each of these 6 faces, you need to find the area separately one by one and then add them together. Try and be smart about it, because in a cube, all the sides, all the faces have the same area. Volume, have a look on your formula sheet. Various volume formulas can be found there. They will be asking you to use them, and most of the time just substitute in values. That's basically it. Oh, no, don't see you shortly. Okay, just like I said, we're just about at the end. Let me just quickly check if we have any questions. No. Okay, so just like when I promised you, there will be a surprise at the end. And this will be, it's time that you test yourself. There was so much content that I have gone through with you very quickly. We've done a whole topic, a whole year worth of concepts in 2 hours. So there's a good chance that some of these contents might have been forgotten, you need a refresher, or you feel like you're very slow at working them out. So I'm going to actually give you a worksheet that you can download where you can test each single one of those concepts in a question. Now, this will be in the link in the description, so you'll have to go back, if you're watching this live, you'll have to go back to the recording when we upload it. So what do we need to do now? Last step, make sure that you know the fundamentals from this lesson. If there's any of these that you're not sure about, use the worksheet to do some practice examples. If you're stuck with any of the fundamentals, it's not too late to ask for help. If you need one-on-one support, you can ask us. You can ask your tutor if you already have one, or you can contact us if you need any help. Thank you very much. I appreciate you guys being here today. And we will see you guys later at a closer time to the exam, where I will do another 2-hour stream. But this time, I will expect that you know the fundamentals, and we will do 2 hours of worked examples over and over, past paper questions, similar questions to what we've had here. If you have any specific questions you would like to request, leave them in the comments, and I'll see you in the next stream.